Hey guys, today's presentation is designing something that's actually buildable with PTC's CREO 3.0. My name is Peter Hartnett. I was a former member of FRC Team 1816, the Green Machine. I graduated last year. I was on the team for the 2013 through 2015 seasons. I was a builder in the 2015 season. I also did most of the CAD for the robot. So why this matters, it's really essential for your robot performance to have something that's actually buildable and to be able to build a product that will perform like it looks like it will in the CAD model. It's often misunderstood by the CAD community. I mean, there's a very big split between the CADers and the builders often, and CADers don't know how to build anything, and the builders don't know how to CAD anything. And so unless there's a really good line of communication there, they end up with a CAD model that's not actually buildable, and the builders have to try to make that into something that can be manufactured. One final thing to note is that an effective design really balances the playing field. It makes it so you can have not fantastic strategy, but you can build a machine that's incredibly reliable, incredibly robust, which is very necessary in most first games. I'll also be going over things that'll make it significantly easier for teams with less resources to build a robot that is competitive with teams that have, mills and lathes and CNC, everything else. Now getting into how to actually do that. The key that we always follow is try to consider how it's going to be manufactured as being designed. Don't wait till you have a fully designed robot to try to figure out how it's going to be manufactured. And that's the issue most CADers often fall into, is they design something that looks great on paper, would work great, but can't ever be built. And so you have to sit down with the builders and try to make something that's buildable, and it takes a significant amount of time, and often you end up rebuilding parts or lots of parts, and this really isn't a great way to go. Another big thing that we always pay attention to is never work in an increment smaller than 1/16 of an inch, and always try to work on standard increments like 1/2 inch, 1/4 inch, 1/8 inch, 1/16 of an inch. That way it makes it significantly easier for builders to measure. And realistically, you're not going to be able to be accurate below a 1/16 of an inch unless you have something like a mill. So realistically, CADers often fall into the trouble of like, oh, we need exactly 12.147 inches. Let's write 12.147 inches in the model, but that's just not doable. Most build teams aren't going to be able to be accurate down to the 100th of an inch, much less 1,000th. A couple of big tricks that make it significantly easier to construct those weird, obscure objects that every robot's going to end up having is using one-to-one drawings. Basically, you print out the part in a drawing that's exactly the same size, and then as you're manufacturing the part, you can check it against that drawing to make sure it's becoming what it should be. It's something we highly recommend for things that are buildable in your shop, but you're afraid you're going to mess up. Say you have a kind of a funky angle, but there's no way to get around it. This is a great way to do it. Another big thing is fabrication jigs. It's something that takes more time to design and develop and build, but for some parts it's absolutely essential. We use them for our container auto this year. There was basically no way to bend our arms to exactly the same shape for every arm without some sort of jig. And so we designed that and built it in wood, and then we could bend our arms without any trouble, without having to look at the other arms that we'd bent. It also gave us the ability to completely follow our CAD model when bending those arms. Something that has to be considered when you're designing is what is available online, or COTS, consumer off-the-shelf parts. There's pretty much every part you could ever imagine available online, and I'll be going over those in a little bit on what different parts are out there and how those can be used to effectively build a game-winning robot. And so it's really essential to be thinking about that stuff as you're going through the process of designing your robot. On pretty much all of our robots, we come to the issue that we don't have the ability to produce one part or a couple parts, and so we have to rely on our sponsors to do that for us. Something that's really key with that is keeping a line of communication open with your sponsors and talking to them early and often. If you need a part done, don't expect it in less than a week, just because it's unfair to them and unrealistic to expect that you're going to be able to get a CNC bracket in 2 days like you could if you bought it off AndyMark or VexPro. Something that's absolutely essential to designing a robot that can be built is designing every last little bit of that robot in CAD before you even touch the final robot. This means all the bracketing you're going to need, all the collars you're going to need, figure out where the chain's going to run, make sure there's no interference anywhere. This is a huge deal. It's going to save you a ton of time in the long run. It takes time, and you feel like an idiot putting in 7,000 1-inch angle brackets, but kind of reiterating the first point, always be thinking about the fabrication of every piece before it's actually constructed. So that's kind of the end of the presentation. I was going to show you some resources that our team uses for all the CAD models of all of our parts. So this is McMaster-Carr. I'm sure you've heard of it. It's pretty much where you can buy anything you need for FRC and just about anything else mechanical you'd ever need. But they're a great resource for CAD models and, to be honest, to buy all the parts you need. So say it's a rod end that we ended up using on our container auto. And as we're designing that, we knew we needed a rod end. We figured out what was about the right size we were going to need. And if you look, pretty much every part will have this product details and a little CAD sign. You click on that and scroll down. You can actually download a CAD file for just about every part on McMaster-Carr. Maybe not all of them, but there's a vast majority have these. And that'll make it so you can design initially with the CAD model and make your life significantly easier when it comes to making sure everything fits and all your angles work and whatnot. So that's just something to be aware of. There's a lot of resources there. Another huge resource that our team uses is the VersaFrame system. Basically, it's a system of tubes that are all pre-drilled to standard holes that are an inch apart or a half inch apart, depending on how you buy it. And it guarantees with their gussets that you can buy, or their mortar mounts that you can buy, or their drivetrain systems that you can buy, that everything's going to fit together the way you want it to. Additionally, they offer different parts for West Coast that make it significantly easier to do that. They also offer on their site gearboxes that are compatible with their VersaFrame system, so just be aware of that. Something to note with VersaFrame is they have a pretty finite amount of different angles that you can buy gussets in, so you have to be very aware of that when you're designing. You have to be very aware of what brackets they actually sell. So there's only certain angles that they'll sell. I mean, it's basically on 30-degree increments or 15-degree increments to some extent, different angled brackets, and so you have to design stuff that fits these. Otherwise, you're going to have to go to a sponsor or make one of these brackets on your own. We sometimes will have our water jetting sponsor water jet brackets similar to these that are in different angles, but we try to avoid it at all costs. It saves us a week of time when it comes to actually manufacturing. And so that's something to be very aware of and be designing based on what you can buy. Keep in mind, you can modify these brackets. So if it's too long, you can cut it shorter. You can be creative with them, but be aware of that. Also be aware that CAD models do exist for all these parts. So like the stuff on McMaster-Carr, you can download it all. And then work that into your model as you're designing it. All right, so now we're going to jump into the CAD model itself. So this is the model of our 2015 robot Zebra, minus banners and a few other things. And a couple things you notice. Obviously, we have those Vexpro gussets just about everywhere. So you have they're 135-degree gussets here, 90-degree gussets. These are modified to be a little bit shorter. And then our whole drive base is all VersaFrame, so it's all pre-drilled tube with 90-degree gussets. These are T gussets, so everything here is made by Vexpro. You simply order it, you cut your tube to length, and then you assemble the thing together with rivets. It was great. We never broke anything, and it keeps everything really, really square, which is a huge deal when you are building robots that are 6.5 feet tall and are taking impacts at 20 miles an hour. Another thing to notice, our whole drivetrain is Vexpro gearboxes. So I don't know if you saw those, but on Vexpro's site, you can buy this configuration and they slap right on there the design to fit around the VersaTube. And it makes your life a lot easier when it comes to drivetrains. So basically our whole drive bases and drivetrains took us a total of about a day and a half to make two for obviously our competition robot and our practice robot. And then we got to the point where we were about 90% done with the robot in about 3.5 days. So that's just something to be very aware of. You can model quickly and effectively and make something that's very, very fast to build. Another thing to notice, we're using just standard West Coast off-the-shelf drive gearboxes. We didn't design our own gearboxes. We didn't feel like we really needed to. You could buy what you really need. This is one of a couple parts on the robot that we had to have custom manufactured for us. This is actually 3D printed spool that we had to collect the cable as it came off of our elevator. Another one of those parts that is kind of important to note are these brackets. So if you look at our arms, they're actually coming out at a pretty strange angle, and that's the angle designed specifically so it hits the center of the containers. And so this is that bracket that does that. Going into the design, we realized it was something that we weren't going to be able to manufacture in-house just because how strange angles is, how thick everything is. There's no way to do this with tube or plexiglass or whatever you'd try to do that with. So we talked to one of our sponsors who has CNC capabilities, and they machine this part for us. And so it's something we wouldn't be able to make in-house, but we had to be very aware of that, and then talk to our sponsors to make sure they could help us out, talk to them well in advance to get these parts done in time for our competition. Yeah, just with the right sponsors, you pretty much can manufacture anything. You just have to be very aware of both of your time and the third and final part on a robot that's actually special is this water jetted plate. Realistically, you didn't need that to be water jetted. You could have just done that with a standard aluminum plate. What we wanted to do is make sure all of our holes lined up, just because it was the main mechanism of our robot. And so we had that water jetted so all of our holes were in exactly the right spot. But like I said, that could have been something that was done off the shelf. Basically on this robot, everything was off the shelf, including the aluminum tube everywhere, which made it significantly easier for us. I mean, you didn't have to try to figure out what a 1/2 inch was. You knew it was the next hole on the tube. And it made manufacturing significantly easier. You could guarantee everything was at just the correct angle and whatnot. So it's a system I highly, highly recommend. And it's a system that's, I mean, really tried and true. Something else to notice with this robot is how pretty much every part it takes to build this robot is included in the model. So you'll notice we're actually using 80/20 slides that we pulled from 80/20's website. We're using all the VexPro parts, the CAD models of those parts. Things like the wheels are actually the CAD models. We're not just throwing in there a 6-inch diameter block. That way we can guarantee we're not going to have interference with anything when we come to actually building the robot. So it's something that takes a little bit of time and a little bit of understanding of where those resources are, where you can get models of stuff, but it will save you tenfold in the long run having stuff that won't interfere with each other. So that's basically all I have for you. If you guys have any questions, you can contact the Green Machine at contact@edanarobotics.com. I'm happy to answer any questions. Otherwise, thanks for watching.